Now that we've talked about some of the properties of exponential functions, let's use those to graph even more exponential functions. So the general form of a transformed exponential function might look something like this. We'll have a base, instead of just raised to x, it might be a base raised to x plus or minus some sort of number. We might multiply that base by a number, base to a power to a number, which we've actually seen before. And we might add a number at the end. This number in front, if we multiply by a number a, that's what we call the vertical stretch. If we add or subtract a number from x, this c is the horizontal shift. X minus c is going to make it right, move it right c, and the plus c, if it was x plus c, would make it move left c units. And then d is going to be a vertical shift. Plus d, if d is positive, would make it go up, and a minus d would make it go down. If a is negative, then we're also going to have a reflection across the x-axis. These might sound familiar. You might have studied these before in 1710 or college algebra when you translated functions like the square root of x. You might have graphed things like square root of x minus 2 with a plus 4 on the outside, and you might have said that this is the graph of the square root function, but it is shifted right 2 and up 4 units. We're going to do the same things here, except for our base parent function is now going to be an exponential function. So in this example here, for both of them, we want to use the graph f of x equals 2 to the x to sketch the graph of two other similar functions. And they're similar functions because they have the same base. They're both 2 to the, right? 2 is the base in both of these, which makes them the same. So I sometimes like to kind of start with a sketch of what my 2 to the x function might look like. So now I need to think about what all of these translations will do to this graph. So in this one, I have a plus 1 out here. And since that plus 1 is not up in my exponent, it's kind of out before, this is going to be like my d. This is going to be a vertical shift up 1 unit. This time the plus 1 was in front of my exponential as opposed to kind of after my exponential like d is there. But that's okay. The point is that it's not adding or subtracting from the x. The other translation we have here comes from this x plus 2. The x plus 2, since we're adding or subtracting right by that x, that's actually going to be the horizontal shift. It's like my c up here. We're going to go left 2 units. Left because it's a plus 2, and it's actually always the opposite of what you think it should be. So what will this function look like? Well, I'm going to take this one that I've sketched in here, right? And I'm going to move it up 1, so it might look more like that. And then I'm going to move it left 2, so it might look more like that. And what I like to do is take a couple key points. So I might start with this one and move it left 2 and up 1, and it would end up there. And then if I take this point here, I take it left 2 and then up 1, it'll end up there. And so then I'm going to sketch in my function. It's helpful to also sketch in the horizontal asymptote we have here. My original function, I probably should have sketched that in, but my x-axis was already kind of that for me, right? It was here. Here, because I've shifted up, my horizontal line will also go up 1. I don't really need to think about the horizontal shift. If I take a flat line and I move it to the left or to the right, if it's an infinitely long line, it doesn't matter. It's the same thing. So my horizontal asymptote will be here. It'll be the equation y equals 1. Let's also think about the domain and the range of this. The domain of my base exponential function is negative infinity to infinity. And if I shift this up 1 and left 2, I still have graph on every single x value. This goes forever this way, and it goes forever this way. All those x values are going to get graph all the way up here. And so my domain is still going to be negative infinity to infinity, even though I've translated it. If we think about the range, remember that's the y values that we have graph for. Because I have shifted this a little bit, shifting it up means that the smallest y value that I get out is not quite 1. I don't get exactly 1, but I get all the values really, really, really close to 1. So instead of my range being 0 to infinity, like it is for just plain old 2 to the x, my range here is going to be 1 to infinity, because I get all of these y values out. And our asymptote, we've already written that, it was y equals 1. Let's try one more for good measure. In part B, we have the function k of x equals negative 2 to the x minus 1. And both the minus 1 and the negative in front of the 2 are going to be some sort of translation. So I have a piece here, and I have a piece here. Both of those are translating my function. X minus 1, this is going to shift it horizontally right 1 unit. The minus in front of my base, really you might think about this as being negative 1 times 2 to the x minus 1. So my a value is negative 1 here. The number multiplying in front is negative 1. The 1 won't do anything, but the negative is going to be a reflection across the x-axis. So again, I'm going to sketch in my base function here. I'm going to move this to the right 1, and then I'm also going to reflect it across the x-axis. I might do this in a couple of steps. If I move it right 1, and then if I reflect this across the x-axis, everything is going to move from the top down to the bottom. So think about a kind of a pancake flipper. All of my values up here are now going to end up down here. So I might have this point and this point and this point. Notice I've kept all those x values the same, but now the y values have flipped down to the negative side. It might be helpful to include a couple more kind of for negative x values. So I'm just going to kind of sketch in a few more points that I'm seeing, and that's going to help me know that this is what my translated function would look like. Now that we have a sketch, we can use that sketch to determine the domain, the range, and the asymptote. My domain here is all the x values we can plug in. My domain is still going to be negative infinity to infinity because I have graph for every single value on my x-axis. And my range now is actually quite different. My range, the y values that I have graphed for, I have graphed down here, and the y values that corresponds with is all of these values. So I would write my range as negative infinity. That's the smallest y value that I can get out, and going all the way up to 0, but not quite 0. Our asymptote actually doesn't change. If I take a horizontal line and I shift it right, it's not going to change. And if I take the line y equals 0 and I reflect it across the x-axis, I'm still going to get y equals 0. So my horizontal asymptote, let's sketch that in. It's still going to be y equals 0, the same as our base 2 to the x. All right, so here we talked about how to go from an equation to a description and from a description to a graph. We can also go from a description to an equation. So here I'm going to want to write the equation of an exponential function with base 5. So 5 will be the thing that has the variable exponent. But I want that to be reflected over the x-axis and shifted down 4 and shifted right 3 and compressed vertically by 1/2. There's a lot of things I want to go on here. We'll maybe do a little bit at a time. So just knowing that it's base 5 tells me I'm going to have 5 to the some sort of power. I'm going to have some sort of power with my variables up in here. 5 is the base for that. So I'll start with this. Okay, and we'll just kind of take these in order. If it is reflected over the x-axis, that tells me I'm going to have a negative out here. I'm going to have a negative out in front if I'm reflecting over the x-axis. My a needs to be negative. If my graph is shifted down 4 and right 3, both of those things are going to be included by adding or subtracting numbers in the right spot. Shifting down 4, let's see, we had things moved up or down before. When things were moved up or down, it was a number way out in front or behind. Let's write it behind in this case. If we're moving down 4, I'm going to have a minus 4. Not on my x. It's not x minus 4. Just out on the outside. Then, moving our graph right 3. Right 3 is where we're going to add or subtract something in here. And moving it right 3 is when we're going to subtract 3. I know I really want it to be add 3, but it's opposite. The last thing we need to think about is the vertical compression by a half, and a vertical stretch or compression happens with the number multiplying out in front of my exponential function. In this case, I'm going to put a 1/2 out in front there. And this is exactly how we would write the equation of the function being described here. This is an exponential function with base 5. It's been reflected over the x-axis. It's been shifted down 4. It's been shifted right 3. And it's been compressed vertically by 1/2.